recorder started.
Oh, can you bring up the projector menu so I can get the model number?
Oh, sure. Right there. It's a PT LB90NTU.
Okay, got it.
Thank you. All right. So I'm gonna pass the roll sheet a little bit later. According to my son's principal, traffic was an issue. Depending on where you are. I think the Midtown area had certain parts have floods. So I think some people may be a little bit late today because the principal sent an email early this morning. It's a K-18 the school. To remind parents that nobody will be counted as late today. So don't rush, don't drive fast. Don't try to go through a puddle. To get to school. Everything is going to be okay. So that kind of tells me that there are maybe traffic congestions due to the rain last night or whatnot.
Mainly on 99.
Mainly on 99.
Yeah.
Okay.
I wonder how many people will actually take that in consideration. Still drive.
Plow through the the rainwater. Yeah. Especially people who drive big SUVs, because of all the commercials, right? Yeah, you can get through that. No problem.
And then you see all these videos of, oh, it's nice and flat there, but this giant sinkhole right there you can't see.
All right, so I'm gonna make sure the size is still visible. Okay, there we go. All right, so I'm gonna start the lecture, because it's gonna be recorded anyway, so people who cannot be here on time, will still be okay if they just watch the recording. Yep, go ahead.
I've not looked at any of the recording yet.
Okay.
Where is it at? I'm not sure.
The recordings are over at YouTube. So if you go to YouTube, you want to look for the channel called Somprofs, SOMEPROFS. So it's SOMEPROFS.
Okay.
So once you locate this channel, you'll click on the videos tab,
Okay.
and then it will list the video recording in a reversed chronological order.
You can easily find it by just typing youtube.com/ and that.
Yeah. So, what Tristan is saying is you can just say youtube.com/someprops. So that works as well.
Okay.
But obviously, having the instruction in the video is not necessarily helpful to help you find the video in the first place. So,
Catch-22.
yep. So you can, so don't look for anything else. What you want to do is to click on the videos tab, because that will list the videos in a reverse chronological order. All right, so back to the class. We'll start with. We're pretty much done with debugging. Last time we talked about the use of a state machine diagram. So for the time being, we're going to just leave it at that, because we don't even know how to do user interactive programming, in this particular class. In the previous class, in cisp363, we have those special blocks that will start execution when you click something or when you swipe something, when you swipe in a canvas. But in this class, we don't have something that easy anymore. Okay. And in order to understand user interface programming, which is the fourth topic, we're going to first talk about user interface class hierarchy, and then we'll talk about methods of user interface classes. These two are relatively short topics. The third one is the big one. Okay, what is an interface? Actually contains not only an explanation of the Java construct, but also how it is used in the context of app programming. The last link here looks like a quiz. If you hover over that, it will say it's a quiz, but it really is not a quiz. It's kind of my second attempt to have a step-by-step lab session. But this one is kind of nice because once you finish it, you can review it just by looking through all the questions, which is a lot easier for you to review the material compared to the previous what we call lessons. in Moodle. So we'll go ahead and start with this one here, user interface hierarchy. Right. This one is really kind of short because I just want to let you know how you can find the user interface class hierarchy and how to make use of it. Because there's no way I can cover, or this class can cover, even maybe a small fraction of all the possible classes. There are just lots and lots of them. Fortunately, they are organized in a class hierarchy, which means if I cover some of the more important ones, the other ones are fairly easy to use, or you can learn it by yourselves too. So it starts off with a statement that talks about how it is convenient to classify user interface objects into classes. This has to do with a lot of the objects, the more quote-unquote evolved objects with more features. They share a huge amount of properties as well as methods with the more primitive objects. So I'll explain that when we get to that point. When we get to this part here, it'll be very clear what I mean by that. So this is a link to an Android package documentation, or this is the root page of all the documentations. I'm going to open this in a new tab. And for the most part, when you read the notes, you should also, when you see a link, it's a good idea to use a new tab to view it, because most likely, you have to go back and forth between the Moodle notes as well as the new page. This is the entire root of the reference manual of the Android programming documentation. This part talks about all the packages. So every single one here is a package. It is not a class. The one reason I know it's not the name of a class nor an interface is because all of these words are lowercase. By convention in Java, the name of a class or the name of an interface should start with an uppercase letter and not a lowercase. Now, since these are all lowercase, we know they are not names of classes. Instead, they are names of packages. Now, some packages are more important to us than others. So I would say, at least for the time being, if you scroll down to widget, okay, so if you go to android.widget, which is all the way down because it's all alphabetically ordered, view is important, and so is widget. Okay, so widget is down here, and view is up here. If you click on one, I'm just going to click on widget here, and once again, I'm going to open a new tab, just so that I can keep track of the history of my browsing. When you look at widget, it is a package. It kind of talks about what a package contains. So in here, the documentation says it contains mostly visual user interface elements to use on your application screen. So that's kind of what we want to talk about today. And when you look through the documentation here, it will first talk about the interfaces. We'll talk about interfaces later, and at this time, I'm going to skip over the interface description, and we'll skip all the way to buttons. Some of the names of these, we'll get to the name of the classes. But some of these classes, may not seem, well, what exactly is that kind of class? What is an array adapter? Well, we haven't really talked about that yet. But some of these look fairly, familiar. A button. So you can click on a button here. I'm going to use a new tab also to open up a button. So a button is a class. Now when you look at the description of a button, this page by itself is going to give you a wealth of information already. Because when you look at the hierarchy, it tells you that a button extends a text view, which is a widget, and a text view extends a view, which is of the view package. And of course, everything are derived from the object from the Java language like package. In other words, this portion of the documentation is already showing you the inheritance hierarchy of a button class, from its ancestors. Are we doing okay so far with this concept? Okay. We already talked about inheritance, with object-oriented programming. So this kind of gives you a pretty good idea of where button stands when it comes to the superclasses hierarchy. It also has the descendants, in other words, the subclasses. A compound button is directly derived from a button, but we also have checkbox, radio button, switch, and toggle button indirectly inheriting from button, which means those are descendants, but they're not direct descendants. They're basically grandkids or more. Okay, they're further down in the inheritance tree. Now, this is really useful because what it tells you is if you cannot find something, let's say you want to change the text, on a button, okay? You may not find a method displayed on this page by default, okay? But that doesn't mean that you cannot change the caption or the text on a button. It simply means that it may be a method of an ancestor of a superclass, okay? You don't have to go track down every single one of these to find out what methods are inherited from the superclasses, because we have this really kind of cool link here and also this one here, inherited methods up here. If you click that link, it will list all of the methods that button is inheriting from its superclasses. And that's across multiple generations of superclasses. So that really gives you a good list of methods that you can use in the button class. Yep.
Can you repeat what's the difference between direct and indirect subclasses again?
Sure. A direct subclass is like a child. It's a child of this particular class, and a indirect subclass would be like grandkids and beyond. So they're not directly inheriting from this class, but they're indirectly inheriting. It's easy to verify too. If I just click on one of these and I look at the inheritance hierarchy, you can see a checkbox is a descendant or subclass of button, but it's going through compound button as an intermediate subclass. So that's what it means when it says it's indirect, because there are at least one other class in between in the inheritance hierarchy. I'm going to close this one because we are not going to deal with the checkbox at this point. So getting back to this document here, this is what a button is, and if I click on inherited methods, it will give me this kind of list of drop-down boxes. In other words, it doesn't combine all of those inherited classes or inherited methods into one big, huge, long list. It is still classified based on the ancestor superclass. In other words, if I just want to focus on the inherited methods from text view, I just click this drop-down box here, and now we have a pretty long list of things already, because a text view forms the basis of a lot of the other widgets. So the next question is, well, how do we find out all the widgets that are subclasses, direct or indirect, of text view? Well, that's pretty easy, okay? Using the technique that I just talked about earlier, all you have to do is to right-click here. So we will display the documentation of text view, and you can see that text view has direct subclasses of buttons, checked text view, chronometer, digital clock, edit text, text clock, and then from the indirect subclasses, it has checkbox, compound button, extract, edit text, and so on as subclasses. So this is a really kind of useful way to navigate through the inheritance tree, because you can go up, you can also go down to find out more specifics about a particular class. Yep.
What does it say known?
What does it say?
Known direct subclasses. Don't they know all of them because they created it?
That's a good question. Why does it say known? I think it has to do with which version of API. This is added in API level 1, which means it starts to exist from the get-go. But as they continue to add more, this list will grow. So we have at least this many subclasses, but there may be additional ones later on. Or it is also possible that internal to Android, they might use some additional subclasses that is not made known to the rest of the development community because they're under alpha or beta testing, and they don't feel like it's ready to be used by the general development community. So I think it's just caution on Android's part, basically making sure that they can add more to this list, but this is the list that is guaranteed. right. So getting back to the button documentation, you can see the text view has a lot of stuff here. In general, the way you interpret this list here is when you see something, there are certain patterns that you can see too. If you see something that's a get, that means you're getting an attribute back. If you see something that is a set, okay, let me just kind of scroll down first. Okay, if you see on, it is an event handler. This is typically used when something happens and the object needs to react to it. And if you scroll all the way down to a whole bunch of set methods, these are for changing attributes of a particular object. So once again, we have the set and the get methods as methods in order to change something in an object instead of directly accessing the fields. So remember last time we kind of talked about how it is not a good idea to directly access a field because the implementation can change later on, which basically means if you directly access a field, you will have to change a lot of your own code. But if we go through a subroutine first, a method first, then you only have to change the method and keep the interface looking exactly the same even though the implementation has changed over time. So are there any questions up to this point about how to navigate in the Android documentation to look for additional help? No other questions? Okay. So here's a question. If someone has published a book to talk about, as a reference manual of the Android development platform, would you buy one?
No.
Depends on if all they did was list methods or provided examples of concrete analysis.
So if it is on top of just
They
the
would have to
reference
add that.
manual, maybe it's worth it,
Yeah, they would
right?
have to add that.
I would say that even if it has sample code, it's still not worth it.
No, they'd have to analyze it and provide like real world.
Right. Or best practices, pitfalls to watch out for. Those would be worth it because that's based on experience of people actually making use of the platform. But if it's really just the reference manual, you can easily locate information more up to date, quicker, and you don't have to carry anything physically when you have your documentation online. Are there any questions at this point? Questions? Okay. So if there are no questions, I'm just going to continue with this one. This is all the stuff that we talked about already. And that's the end of this slide. Really short slide. It just tells you where you can find the information and how do you navigate in the inheritance hierarchy so you can look up the superclass, subclasses, and so on. So this is a fairly short one. There's not a whole lot to this part. Getting back to the topic, we'll move on to the second one, methods of user interface classes. And this is also a short one. If you look through the notes here, it's pretty short, stuff that we talked about already. There are generally, three main categories. There are many other as well, but these are the three main categories of methods. The get ones, allows you to get the status of a particular object. The set ones allows you to change those particular attributes and properties of a widget. And many other objects or classes also have these types of methods. And the on method are basically a handler for a particular thing. And the big question is, how do we find out which method to use? Well, that really is the big learning curve of application app programming or any type of programming involving a user interface. This is the big learning curve. It's not the programming language itself. It's not Java itself, because as a programming language, Java is not really that complicated. I mean, most people can master that. I would say in about 2 semesters or so, you can become a fairly good Java programmer. The big learning curve really has to do with knowing what classes to use and what methods are available in which class to do what. That really is the big learning curve. On the other hand, since we have Google and other search engines, that really helps when it comes to learning how to do something. A lot of people just go to stackoverflow.com and post a question, and I would suspect 80% of those questions come from students taking classes, trying to figure out something, how to do something. If you go to ask.com, This is really funny. If you go to ask.com, a lot of the questions are directly copied and pasted from homework assignments. Which is kind of sad in a way, because it's just, some students not thinking about it and just asking and see if anyone can give them the answer. There is a fourth category. The fourth category is kind of like a get, but it is starting with the word is, which basically implies it is returning a Boolean value to indicate whether something is true or false. Yep.
It's funny, on Stack Overflow, a lot of those people will post a question, and some of them will be honest about it. Hey, this is a homework assignment. But a lot of them are like, I'm trying to write a program. No, you're trying to do a homework assignment.
Because when you look at the content or the question itself, it is not something that is typical of an actual project, an actual at work kind of project. Okay, so here we are moving on to the third one, which is the bulk of today's discussion. I think we have enough time to go over this one. I just clicked it instead of right-clicking. Right-click here, and start on this one. Okay, so this is a pretty, depends on how far you guys want to go, when it comes to talking about, the interface as a programming language construct, which is somewhat independent to this being an app programming class, but I think it is important to understand what it is before we actually make use of it. Okay. So let's go ahead and start with this one here. Java has a language construct called interface, not to be confused with a quote-unquote user interface. In other words, when you're doing Java programming, the word interface has a very, very specific meaning. Okay? It does not imply any type of user interface. It does not imply any type of network interface. It is a computer programming language construct. Okay? It is unique to Java. Visual Basic has something similar to this, but not exactly the same, and it's also not called an interface. The first thing you want to understand is an interface is not a class. It is not a special kind of class. It is simply not a class. Okay? So those two concepts, a class versus an interface, they may seem like they are similar, but they are not the same concept. Okay, they're distinctly different concepts in Java programming. Now, what do you use a class for? A class is, one purpose that you can use a class for is to use it to quote-unquote stamp out cookies, because a class is like a cookie cutter. And as a result, with a cookie cutter, and you have cookie dough, which is basically the memory allocated for your Java virtual machine, you can use a class to basically create objects. Okay. And we call those cookies in this class because cookie cutters are classes. You can, in Java programming, you can have classes where they are not possible to stamp out cookies. They're called abstract classes. That concept is kind of the same as in C++ as well, because you can have abstract classes in C++. And with those classes, you cannot stamp out objects. And the purpose of those classes, the abstract classes where you cannot use it as a cookie cutter, it's still useful for organizing methods and also fields more efficiently. So you basically define everything that is common to all the objects of the subclasses into the superclass, so they don't have to be redefined over and over again. It's for organization purposes. Are we still doing okay so far with the two purposes so far discussed about classes? So one is we use classes to actually create stamp out objects. So that's one purpose of a class. The second purpose of a class, which mainly applies to all classes, the first one applies only to non-abstract classes, but the second one applies to abstract classes as well as non-abstract classes, is for organization purposes. And of course, the last sentence of this paragraph is the most important one. Interfaces are not used for those two purposes. In other words, you do not use interfaces to organize common attributes of objects. And two, you do not use interfaces to create objects. They are not cookie cutters. Are we doing okay so far? Okay, have I established what interfaces are not? Yep, go ahead.
Well, create, in your description, I think further down, you talk about creating what we call dummy methods, right? That essentially defines the
Callback
parameter.
methods?
I think you call, I forgot where I read it, but sort of dummy methods where it's just, you define the parameters of the method, but it may not necessarily define how it's implemented.
Like a stub method?
Like a stub method. That's called it's called a virtual method in C++. Abstract.
Yeah, or maybe abstract, yeah.
Right, but it's still not for the purpose of stamping out something. Interfaces cannot stamp out objects.
Right. But interfaces, well, maybe I'll let you continue asking.
Okay. Yeah, when we get to that point, you can probably ask that question again. Okay, so this is just really a quick summary of what interfaces are not. They cannot be used to create objects, and a class cannot inherit from an interface. You can inherit from a class, but you cannot inherit from an interface. So what exactly are they good for? Well, here's a documentation from Oracle. Oracle has a fairly concise description of an interface is and what it is for. So I'm going to open up a new tab here. And this time we're going to the Oracle website. I'm not going to read this whole thing here, because it's really kind of something that you should be reading. It's a long discussion. It's kind of describing it using an example, and talking about in general in terms of the concept how would how would a developer make use of an interface. To me, this is not it's not meaty enough. Okay, it talks about the philosophical differences between an interface and a class. And to me, that's somewhat of an artificial, differentiation. It's not, really quite enough for me to get a good handle on the concept. So you can read it, also, but it's not exactly sufficient, in my opinion, to explain, how an interface is different from a class. From that description, one can easily argue that an interface, what can be done with an interface can also be done with a class. In the case of the operate car example, one can create a superclass instead of an interface and define the methods either as abstract methods, basically they are methods that have no bodies, basically just a stub, or methods with a dummy operation. Then the class operate BMW 760i, which tells you how much money Oracle software engineers make. See, I would have mentioned, Civic Hybrid or, Focus. Inherits from operate car and use methods override to handle the specialization of the methods. In other words, that documentation, in a way, fails to explain the true difference between an interface and a class, because the only example that is given can also be done using classes. Okay, so to me, it's a good start, but it doesn't really quite get to the point. There's also a separate document. Oracle also compares abstract classes with interfaces. So I'm going to open up as a new tab here too. So this one, is a little bit more meaty. It has actual more code in it and more discussion. And it also tells you, which one should you use, abstract classes or interfaces. And it has some questions where you can answer. But once again, even with this list of questions, it's still fuzzy to me. Okay, it still seem and feel kind of really fuzzy. Is it definitely abstract classes or is it definitely interfaces? It doesn't tell me any of that. Okay, it's not technical. Okay, it is not technical enough for me because it's still kind of depending on how you look at things. So once again, you can right-click and view it on your own, especially if you have already taken cisp 400, which is object-oriented programming, and you have some understanding of what is an abstract class already. Then this would be a good article to read. How many people have taken cisp 400 or 401? Okay, so a few people. Those are really good classes to take, especially after this class too. You can take that class before or after this class, and I think it will help boost your understanding of app programming because we are using Java, And in this class, we're kind of introducing Java programming concepts as we need to, but that class will give you a much more in-depth treatment of Java specific. 401 will give you a much more in-depth treatment of Java constructs. All right, so here is my own explanation and my own differentiation between the class versus an interface. So we can assume that class A is a superclass of class B, and object O is created from class B. And here I have just broken one of the conventions because O should be a lowercase because it's an object. Using the classification term, we can then say object O is an instance of B, but it is also an instance of A due to inheritance. It's just kind of like me catching a fly in a jar, and I can point to the jar and say the animal inside this jar, which is living, flying, and eating and pooping at the time, is a fly. Okay, this living organism is a fly. But I can also say this living organism is an insect, because insect is a superclass of the fly classification. But on top of that, I can also say, hey, I have an animal within this jar because an insect is also an animal. Is that working out so far? Okay. In other words, I can keep abstracting it until I get to the overall, the root classification. Because the last classification is I can point to the jar and say I have a living thing inside this jar, because all animals are living things. Is that okay so far? So it's a hierarchy of classification when it comes to classes. Now, an interface is a little bit different. The way I describe it is one way to describe it, but later on we have a much more concrete example, a coding example to illustrate it. So let us assume that interface I, uppercase I, is an interface, and class C implements it. In other words, instead of using the word inheriting from a superclass, when it comes to interfaces, a class implements a particular interface. So it's just a different word, right? But it actually has more meaning than just saying, oh, it's a different word, but it actually means something. Object O is created from class C. In other words, we can say that object O satisfies all the requirements of interface I. In this case, that's how we can say it. In other words, we do not say that object O is an interface I. We will say object O meets all the requirements of interface I. It's not inheriting, it is just saying that, okay, it meets the requirements of interface I. Are we doing okay so far at this point? So kind of? No? Okay.
What's an interface again?
An interface is not a class. You cannot use an interface to create objects. So far we have only explained what it is not, and this is the entry point of defining what it is. Okay? So there'll be a little bit more later on. Okay? I promise you that we will get to the bottom of this in today's lecture. Okay, that's one of the main purposes, is to clarify what an interface is, because later on we will be using that language construct, and I do want everybody to understand what it is before we talk about how to use it. Is that okay? Okay. All right. So maybe, let me see. Okay, so we'll go ahead and take a look at this example here first. Okay, this example is fairly simple as a Java program. It's obviously it's not gonna compile because the package names and also the class names are all kind of just really simplistic just for this example. So here we have this is package XYZ. It doesn't even matter because nobody else is going to refer to this package here. I'm importing PQR, which means R is a class that I'm importing from some other packages. And I'm defining my own class C here. I'm defining a method of class C. It requires a reference R to class R, uppercase R here. And we'll go ahead and invoke the G method of this particular object, which is of class uppercase R. Okay, that's the definition of this entire class. So that means as long as we pass an argument to this particular method, and as long as the argument we are passing to method f is either of class R or a subclass thereof. In other words, if class R has a subclass of S and we use class S to create an object, we can use that object to pass as an argument to this particular method. Is that okay so far? Because that one is actually an object-oriented programming concept already. Is when the requirement is class R as a parameter, you can actually use any object that is in an instance of a subclass of any subclass of R class R, it will still be okay. Is that concept okay sinking in? So you can always start with something that's more specialized, from a subclass, but when it's time to abstract it and say, oh, you know what, we don't need to know all of those extra details. I just need to guarantee that it can do this part here. We can always cast a reference of a subclass to a reference to a superclass. That operation is always permitted. It's okay to lose information. We kind of do okay with that concept. I can give you an example later on too. So this paragraph just kind of explain what I said a little bit earlier. How does an interface make any difference? The basic mechanism to cast an interface is fundamentally different from that casting to a superclass. So when you have an object of class R and you want to cast it to a superclass, it's different. And this is where I can skip to this picture. I think a picture is a lot easier to understand in this case. So if you look at the top one, I'm going to hide the bottom one for the time being. Okay, so if you look at this triangle here, or these, there are 3 nested triangles. So in this picture, I'm not going to read the text here. I'm just going to explain it. If you look at this smaller triangle here, the blue one represents a superclass of the entire hierarchy. So you can kind of look at this as java.language.object. Okay, that's the superclass of the other 2 classes. Are we doing okay so far in terms of what the triangle and the color means? Okay, that's the superclass. It starts everything. And then if you look at the teal color one, which is this larger triangle, it is a subclass of the blue one. Okay, it's representing a subclass of the blue subclass. And then when you look at the burgundy one, it is a subclass of the teal one. Okay, so what exactly is this picture representing? Well, it's representing that the portion that you can actually see is in teal color. That's the extension of a subclass to a superclass. Okay, but what about the portion that is overlapping? What about the portion, the tip portion here? What about this portion here that is overlapping between the superclass and the subclass? Well, it's common, right? It's common to both classes, and so we are not redefining. That's why it is not in teal color. It is just in blue color, because the superclass is already defining that portion. There's no need for the subclass to mention that again. That's the whole idea of inheritance, is so that we don't have to redefine a lot of stuff over and over and over again. The burgundy subclass is the same way, because the area they can actually see is in burgundy. It's only this portion here. It looks like a trapezoid. Okay, that's because whatever is already defined in the superclass in blue and the superclass in teal, they all of those definitions do not need to be redefined. So the subclass in this hierarchy only has to define stuff that is an extension to those of the superclasses. In this case, there are 2 superclasses to the burgundy subclass. Are we still doing okay so far? Yep, go ahead.
Would the yellow dot be the manifest class?
The yellow dot is a method that is a part of the superclass. So the superclass represented by the blue triangle is the one that contains the method represented by a yellow dot, okay, by the yellow circle. Okay, so with this inheritance hierarchy, then we can say if a parameter of a method is requiring just the class of the represented by the blue triangle, you can pass any object of the subclasses just fine, because any object created by the teal subclass or the burgundy subclass, they automatically have the yellow circle. Is that making any sense? Because the yellow circle is common to all three classes because it is by inheritance. Yep.
So if you have a method that in the subclass that redefines the method of the superclass,
Right. The overrides, not redefined, overrides.
Overrides.
Right.
Is there still a way to access the superclass method?
Yes. Yes. That's a very good question, because okay, let me just kind of rephrase your question so that my recorder can record it. The question is, if the burgundy subclass in this case is overriding the yellow circle, which is defined by the superclass here, the question is, when we pass a reference of that object to a method, which method will it use? Would it use the method originally defined by the blue portion, or will it use the overridden, or overriding definition, which is defined in the burgundy portion? That's basically the core of your question, right? The answer is, it will, in Java, by default, it is going to use the burgundy one. So whatever is the most evolved form of a method, it will automatically use that. Even when you pass the object as a blue superclass reference, it will still use the overriding method in Java. That's a very good question, because that's also one big distinction between Java and C++. Because in Java, everything is virtual by default. If I use C++ terminology, every method is quote unquote virtual in Java, unless you specifically say it is not.
So let me repeat what you said and see if I understand it correctly. So if you pass a subclass into a method, and the method calls for the type for the object to be passed is a superclass. The method within that method, when it invokes a method,
Okay.
in that it would be the subclass method.
Correct. Yes.
Okay.
So the best way to explain that, probably is to use a, simple program. It's not going to compile. I'm going to create this on the fly here. So let's say we have class A as a superclass. Okay. So class A is a pretty simple one, and we'll just say public void f, and all it's going to do is, okay, so it's going to do an action that I just called block. Okay, doesn't matter what it is, and we'll create a subclass of this. So we'll say class B is extends class A, because class A is a class, and once again it has the same thing. It has a public a method called f with no parameters, returning void. And of course, in this case, I really need to should use override here. The add override, once again, is a annotation. It tells the compiler to double check for me, please, that this method f is in fact overriding a method that is already defined in class A. In other words, if I have a little typo here in class A, this is in fact method G and not method F. Now the compiler will come back and complain to me and say, hey, you thought that you were overriding something. You're not. There's no such thing to override in the superclass. So that's why you want to use add override, because it gives the compiler a little bit more information of what to check for you to make sure that your program is going to do what it intends. Yep.
Is add override, is that a Java thing, or is that an
It is a
Android?
Java thing.
Okay.
Yeah, it's a Java thing, and as far as I know, is missing from C++. Okay, so let's say f here is going to do yada 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 yada. Okay. All right. So here we have let's say we have another class here. We have class C, and it is independent to the other two classes. Doesn't matter. It has its own method, public void. We call this G, and G requires a single parameter. The single parameter is requiring is of class A, not class B. It's only class A. And we'll call this obj for object. And method G of class C is going to say, hey, obj as a reference to an object, go ahead and invoke your f method. Okay? So everything looks okay at this point, because as far as we know, this code should always do blah, right? Because the class definition of this parameter is class A. And if you look up the definition of class A, the f method is going to do blah. And so we think, okay, or most people starting to program in Java will think that this will invoke blah, or invoke the method that will actually do blah. Okay, so here's the, so somewhere along the program, okay, probably in another class somewhere, it doesn't matter where it is. So we have a variable, okay, so we have a variable which starts with a b, okay, so b is objb here. Okay. In Java, what do you think this line is going to do on its own? Okay, I'll give you a few choices. One, it is a declaration. It is simply saying that objb is a reference to a object of class B. Okay, I'm just allocating a small little chunk of memory and say that this is a reference. It will be, or it's going to be a reference to a class B object. Or does it do what I just said, and also at the same time allocate a class B object from the heap or from memory, and make object B a reference to the newly allocated object? Okay, one or the other.
It will eventually be a new reference.
It will be the first choice, right? The first choice is simply saying that objb is a reference to a class B object. But at this point, it is a reference to nothing. Yep.
Quick question: if object B is a default constructor that still does the same behavior?
Yes. Because all you're declaring is a reference. Yeah, you're declaring a reference and not an actual object.
So different from C.
Correct. That is very different from C++. And the worst part about the Java versus C++ thing is the syntax is almost the same. And yet they mean entirely different things when it comes to this sort of thing. So in order for object B to actually refer to an object, one way to do it, one of many, is to do something like this. You basically say objb, object B, is now assigned the reference to a new object we are actually allocating at the same time, and then you need to use this as a default constructor. So B, uppercase B, open parenthesis, close parenthesis, is the selection of a constructor. You can have other constructors too, but I'm using a quote-unquote what we call a default constructor, which does not take any parameters. Okay, it's just open and close paren and say, okay, give me an initialized object of class B, but use the default method of initializing it. Okay, am I doing okay so far with this part here? Okay, so this is not even the most confusing part. The most confusing part is something like this. I also need a class C object here, so we'll say class C is objc, and you can also combine the initialization onto the same line. I typically do not like that approach, so I always separate it into its own line. Okay, so class C or objc is a reference to a class C object. Okay, so that part is not too hard. So here comes the most confusing part. The most confusing part is to say objc dot G. Okay, so I'm invoking method G of object C, and it's taking an object of class A. So what I'm going to do here is I'm going to pass my reference to object B instead, or objb, which is a reference to a class B object. The Java compiler will take this and say, okay, not a problem. Okay, but it seems like we should have a problem, right? Because according to the method prototype, or the parameter list is expecting a reference to a class A object, and yet I'm passing a reference to a class B object in place of a class A object. But that's perfectly okay, because what it is saying, if you look at class C method G, what it's really saying is, I want an animal. I want a reference to an animal. That's what it's saying. OBJB is a reference to a fly. Okay? So the question is, if the subroutine is expecting an animal, and you're giving the subroutine a fly, does it meet all the requirements? Yeah, it does. I mean, it's okay, no problem. And that's why, but the other thing is, when we actually invoke the F method here, which one is it going to do? Is it going to do blah, which is defined in class A, or is it going to do yada yada, which is defined in class B? Okay, so what do you think?
B.
It's going to be the one in class B. Okay, and that's a marked difference between C++ and Java, because unless you use the word virtual in C++, it's going to automatically use blah if I use something like this in C++. But in Java, every method is virtual, and as a result, it will use the most evolved overriding definition, if there is one. Yep.
So the other part of my question was, okay, in class C, where it invokes the method F, if I truly want to use the superclass method F, how do I specify that?
I believe you can do that. Okay, but do you want to choose to do that in here, or do you want to choose to do it in here? That is the question. Because if you want to do it in here, the easy way to do it is to say super F.
Yeah.
Because that will basically invoke the definition in the superclass of B, and it will actually end up doing blah instead of yada yada, or in addition to yada yada.
Right. But yeah, in this case, I'm in class C. Actually want to use the superclass method.
That would be kind of tricky, because do you really want to do that? I'm not sure whether you can or cannot do something like this. Okay, that I'm not sure.
Okay.
Yeah. Because in general,
Yeah. For
okay.
example, there's multiple layers.
Actually, okay, this won't work. Because what this is going to do is it will try to find a superclass of class A. Because the reference is already tied into class A, so when you refer to the superclass of the reference, it will want to refer to the superclass of class A and not class B. In other words, once you get in here, there's no way to know whether the object is really of class B or class A. You only know that it is a class A or subclass thereof. Okay. So that's a good question, and it also helps to kind of point out what I mean by this triangle. So are we still doing okay so far with the concept of inheritance? Now, why do I choose to use a picture like this to represent it? Well, it's because every time you pass a reference to an object, either of the blue color, the teal color, or the burgundy color, the relative location of the yellow circle from the top tip of the triangle does not change. Okay? In other words, if I make the subclass if I make an object out of the burgundy class, subclass in this case, the relative location from the top of the triangle to the yellow circle is the same as an object of the teal class or an object of the blue class. Is that okay so far? Kind of. And that's how a parameter expecting a class in blue can take on actual references of objects can take on objects of the subclass teal or the subclass burgundy, because they can still locate everything that belongs to the super class. Are we still doing okay so far with that concept? Okay. So that's how superclasses work. Now, using this particular method, now let me switch back to my notepad here. So in here, if this is the way I define class C, then every time I want to pass a reference to an object into method G, it has to be a subclass of class A. Is that making any sense? Okay, because we have this fantastic mechanism of being able to pass a reference of an object of any class, starting with class A and subclasses thereof. So I can be like 50 levels of down, 50 levels down as a subclass, create an object out of it, and still be able to pass it as the parameter to method G here. Because eventually it can trace its ancestry all the way back to what we want here. But that also places a very severe restriction in Java, because every class can only have up to one superclass. So if I use up that one superclass just because method G wants to use a subclass or a class A or subclass of thereof as a parameter, then I have just locked down everything to be of a subclass of class A, and it cannot be a subclass of anything else because every class can only have up to one superclass. Am I making any sense so far? That is a very strict and severe limitation. It's kind of like telling you, you know what, if you want to join, any type of group, okay, religious, sports, or whatnot, you can only pick one. Okay, you cannot join a religious group and a Linux user group at the same time. You have to pick one. Okay, you can only have one extra group, one group to belong to. That's the restriction based on classes in Java programming. Am I doing okay so far with that analogy? Okay, so that's why there's a limitation here, and the limitation has to do with the implementation, and it's because in implementation it is using this fixed offset from the beginning of an object to locate a particular either method or a particular instance variable in the object. Okay, it's using a fixed distance to do it, and as a result, you have this really kind of severe limitation of restricting to only one superclass, and it's not convenient, in many cases. Are we still doing okay so far with this? Okay. So what about interfaces? I mean, interfaces are about the same thing, isn't it? Well, not exactly. With an interface which is represented in green in this picture, okay, I think the teal and the green looks about the same on this screen, but they are actually different. In terms of the inheritance hierarchy, it's exactly the same as last time. Yep, go ahead.
When you say fixed distance, you mean conceptually speaking?
No, I mean in terms of the internal representation of an object, it maintains what we call a method table. And in the method table, they actually have ordered entries of all the methods that the object is associated with. Okay, but as a table, which is basically an array, you have ordering, amongst the entries. So what I'm saying is, within that table, which is an array, you have, okay, let's say this is the method table related to a particular object. And if we use that picture here, the first portion of the table will be methods related to the blue one. Okay, so this would be related to the blue superclass in this case. This portion will be entries related to the teal portion, okay, or the teal or the superclass represented in teal in the picture. So we have teal here, and then the rest of it will be the one represented by the burgundy portion. Am I doing okay so far? And it applies, this particular way of looking at things applies to the instance variables, which are called fields, and also applies to methods, of a particular subclass, subclass in this case. Okay, so when you have a pointer, okay, now I'm getting into the really dangerous part because I'm now actually looking into the implementation of something. But what the object, what the reference is referring to, at some point it refers to the beginning part of this table. Okay? When you cast a subclass like the burgundy one into a superclass, which is the blue portion here, you're just telling the compiler, hey, just take a look at this portion here, forget the rest. So it's okay. It's perfectly okay if the yellow circle is here. It's still accessible. Am I making any sense? And that's what I mean by a fixed offset, because it is from the beginning of the method table to the entry that you want to use. That is a fixed offset. Yep.
So if the method's redefined into till,
That means this table is updated. So it points to a different method from the one that it used to point to.
okay, so it would, okay.
And this table, or a reference to this table, is packaged with the object itself. So that's why it's a sticky thing. That's why the overriding method is quote unquote sticky to the object. It's not sticky to the static class definition. It is actually sticky to the object itself. Even if you cast a class B object to a class A, it will still remember the overriding definition and not the original definition, because this entry in the table is actually overridden.
And then, so until the table until are only methods that are defined until, and it's not.
Does not
defined
include
as
the overriding ones.
over.
Correct. Okay. Now, I understand this discussion can be a little bit confusing, especially for people who have not taken an object-oriented programming class. So for the time being, I'm not going to test you guys on these, concepts in Java programming, because this is not a Java programming class. But I do want to give you at least some exposure. If you can absorb, 10% of this, that's good. It's not a problem. But when you later on take an actual Java programming class or an object-oriented programming class, I think this will help you and go, oh, okay, I've seen that before. Okay, so getting back to this example here. So the green portion here is an interface, okay? So this is the representation in this picture. It's an interface. An interface is simply saying, hey, you know what? I need anything that can be quote-unquote classified as this interface needs to give me a yellow circle and need to give me an orange circle. In other words, you can kind of look at it as a filter, as a constraint, and say anything that can pass through the green portion needs to have these things. Okay, I need to have a yellow circle and I need to have an orange circle. I don't care where they come from. In other words, the offset of the yellow circle from the beginning and the offset of the orange circle from the beginning, they don't matter anymore, because this is a mapping. It can map from anywhere within the triangle to here. It can map from anywhere within the big triangle to here. Yep.
So when you implement, it's always the base class? Or how do you implement?
How do I implement? No, in this case, it would be the burgundy subclass implementing the green interface.
Okay.
But because the yellow portion is actually inherited by the superclass, it's okay. It's no problem. In other words, it's really just looking for things that is exposed that meets the requirements. And the requirements in this case will be the return type, the parameter types, and that's the signature of a method. As long as the signature of a method of whatever class you want to use to implement an interface matches everything, it's okay, not a problem. Okay? So you can imagine that I can have another hierarchy of classes, entirely separate from this one, and as long as there's a yellow circle and an orange circle, that other entire subclass, class hierarchy can also implement the green interface. Because somewhere along that hierarchy, I can find a yellow circle and an orange circle. As long as the colors match, it's okay. Now, everything after this point, okay, if you look at it from the right-hand side of the green rectangle, that's all that you can see, okay? In other words, if I say a particular thing meets all the requirements of an interface, the only thing you know about that something is, in this case, it has a yellow circle, it has a green circle. What about the other stuff? What about all the other stuff of the triangles? We lost access to all of that stuff. The only thing we can see would be the yellow circle and the orange circle. Yep.
Does the superclass, the blue superclass, need to also have a implementation of the red circle?
Nope.
It doesn't
It's not
necessary.
Nope.
So, does it implement only methods, or does it do instance variables also?
That's a good question, and I have the answer to that too. The question is, when you have an interface, does it only remap the methods, or can it also remap variables? The answer is it can only remap methods. Any type of fields within the triangle cannot be remapped unless it is a static variable within the class. Now, we haven't really talked about static variables within the class because all of the variables that we have talked about are instance variables. In other words, each instance, each object has its own version of that variable. When we talk about a static variable, it means the entire class shares a single variable. And there are very limited use of a static variable, and that's why I have not even talked about that. Yep.
So I have a question on your statement at the first paragraph. Another purpose of classes is to use inherit. Oh, okay, wait.
Okay, where is
ignore
the first?
What I said. I
Okay.
thought. No, ignore what I said.
Okay.
I'm
He's
asking.
thinking out loud.
Okay.
I'm thinking out loud. Yeah.
Well, I have many people have said that my writing, usually is for some reason it's confusing. So it's not. So you wouldn't be the first one who have to read my own text a few
fine.
times. Sometimes I have to read something that I wrote several months ago and go like, what did I mean by that? And I have to read it again and again and again. Oh, okay, so that's what I meant.
Very reassuring tech.
Well, I mean, we are all humans, right? In fact, I would like my students to be better than I am. That's how progress can be made, right?
You're asking too much.
I'm asking too much. No, I'm not. Okay, so are there any questions about the mechanism of an interface as opposed to the mechanism of inheritance? So if you compare these two pictures, and let me just kind of zoom out one notch so we can see both triangles. So focus on the picture and not the words. Okay, so are there any questions about the two mechanisms? When we use the method of class inheritance, it's based on a fixed offset from the beginning to a particular thing that we want to access. Okay, and that's why one class can only have up to one superclass, because you can only have, there's only one beginning point, and that's why there's only one superclass that you can inherit from. The second method is basically saying, oh, okay, you get to keep this part here, but in order to implement an interface, we have a separate table representing the interface, and that's a remap from the class definition. In other words, in this case, the green rectangle here is represented by a separate table with two entries. And now you can pick and choose which entry from this table goes to the first entry here, and which entry from other parts goes to the second entry. And they have to be matched by name of the method, return type of the method, as well as all the parameters of the method. Okay, but as long as all of those things match, the compiler can automatically pick, oh, okay, this method here matches the description of this method here. This method matches the description of this method here. And from the outside world, okay, so here's the outside world, they can only see through the interface to whatever else is implementing this method or implementing this interface. Yep.
So if you implement green in a class, you're limited to those methods?
If you're implementing green
into...
So you're using a class to implement the green interface, right?
Are you limited to those methods?
Right. If you're accessing an object through as a reference through an interface, then you're only limited to whatever is exposed by the interface.
Okay.
And there's no other way to get around it. You cannot say, oh, okay, so I can see that you have a yellow dot and an orange dot, but what was you before that? There's no way you can answer that question. You can no longer know that it is of superclass blue or subclass teal or subclass burgundy in this case.
So is it safe to say if you have a class that implements something, it's a class with a very specific role?
Say that again?
If you have a class that implements something, it has a very specific role, that class?
The interface defines the role, yes. In other words, okay, that's an excellent analogy. I like that. Okay. So in terms of inheritance, if you look at real people, we do have multiple inheritance because we have father and mother, right? Until we know how to clone human beings, that's how things will be, right? So we do have quote unquote binary inheritance because we have two superclasses to inherit from. Okay, and that's a restriction. Okay, you cannot have 3 parents or 4 biological parents. It just doesn't work at this point until such time we can cut and splice and manipulate our genetics. We can only inherit from 2 parents. Is that okay so far? Okay. But on the other hand, an interface is a role of you, okay, as a person. Okay. So right now I am playing the role of a professor, okay, in this capacity as a professor. You are playing the role of a student at this point. Comes noontime, you're gonna walk out of this classroom. I'm gonna walk out of this classroom. So I'll be another person, right? I might take on the role of a parent and go pick up my kids. You might become, an employee, take on the role of an employee, when you go to work, or you might take on the role of an employer, if you are the employer of, or you're the boss of a company. So those are the roles of you, and there's no restriction as to how many roles you can take on. But there is a restriction of how, your inheritance, how many parents can you inherit from. So all your genetic traits can only come from 2 people instead of, more than 2. Is that making any sense? So that was a really great analogy. I like, when I heard of that term role, I go like, ding. That was good. Was it helpful? I mean, is that new analogy helpful? That an interface is kind of more like a role that you can take on, whereas inheritance is truly, your genetic makeup can only come from 2 people. All right, that's good. All right, so after this all kind of theoretical discussion, yes, go ahead.
So in this case, we could say the burgundy class implements that green interface.
Correct, yes, absolutely.
But
the burgundy class implements the green interface.
But we cannot say that the teal class implements that interface.
That is correct. If you try to use the teal class, when you define the teal class and you say, oh, I want you to implement the green interface, the compiler will come back with an error message, probably going to say that the orange method specified in the green interface is missing in the teal class. Yep.
And is it possible, for example, the teal class implements the orange method also, right?
It is
then-
possible, okay,
and then that the burgundy overwrites
yes,
that method.
yep,
Okay.
yep, that's possible. Yeah, because the overriding mechanism, is entirely different compared to the inheritance mechanism. Inheritance, if you're extending a class, you're adding more entries to the table. Okay? When a subclass overrides something, it is overriding an entry in the previous portion of the table. Is that okay?
I want to
Yep.
clarify, did you just say that you can get the orange method if you implement green from the teal?
It won't. The way it is right now, it won't work because the orange bubble or the orange circle is only found in the burgundy portion. So as a result, you cannot use the teal class to implement the green method because it's lacking the orange circle. Now each bubble is representing a method, right? So this means the yellow circle is a method that is defined in the superclass, the blue one. And the first time a method represented by the orange circle is presented is in the burgundy portion. Neither the blue nor the teal version has a method defined that will meet the orange bubble requirement. But this gives you a lot of flexibility because it's really in the end, when you look at the entire triangle, which is the class that is implementing the green rectangle, it looks at the entire thing. It's not just looking at the subclass. It's not just looking at the superclass. In this case, it's looking at the entire thing with everything inherited. It's just saying, okay, of everything that is already inherited, is there a match for the yellow circle? Is there a match for the orange circle? If there is a match, then this subclass can implement the green interface. So that gives you a great deal of flexibility.
So when you're implementing, you're always implementing from the base class?
Base
Or
class.
Like the blue class?
No, this is the burgundy. In this case, only the burgundy class can implement the green interface. Because only the burgundy class also has the orange circle. If you try to use the blue class to implement the green interface, the compiler will come back and fail because if you just look at this portion here,
Okay,
it's
that makes
lacking
sense.
the orange
Yeah, that
circle.
makes sense.
So the
Yeah.
compiler says, hey, I cannot find a match for a required method of the interface in the base class, which is only represented in blue. But the compiler is really only making a match based on the signature of a method, which is defined by the return type, the name of the method, and also the types of all of the parameters. As long as those things match, it will just say, oh, okay, this one matches this method here, and the other one matches the other method, and it will just make this map here.
So when you're creating a class and you want to implement methods in an interface, you don't have to necessarily declare which interface you're using, whether that method belongs to an interface.
That is correct, because the matching is done by the compiler based on the signature of the methods. So the compiler will automatically check when you say class A implements I, when you declare a class, when you define a class, it will automatically check to see if all of the methods defined in the interface have a matching method in the class definition. Now it can be inherited, which is what I'm demonstrating here, but it has to find it somewhere within the inheritance hierarchy. Are we still doing okay so far with this interface discussion? So if anything, just bring home the concept of genetic inheritance versus role of a person. Okay, different things, different roles a person can take on, and the role is basically an interface in this case. All right, so this is all good. And here we talk about the practical use of interfaces. which is kind of a little bit digression too, because one practical use of an interface is to use it to implement what we call a callback function. A callback function, if you want to have a mental picture of what it is a name card. Okay? In other words, I am a event listener. Okay? An event listener is basically something that is representing the logic of saying, okay, if that happens, I know how to handle it. Okay? So what I'm going to do is I'm going to give you my name card. And I'll say, well, in case of this happening, call me. Okay? And then I'll just kind of go back in my office and do nothing, right? So when that something does happen, when you detect that something happens, you look up all your entire stack of name cards and you say, okay, we have this happening. Who can handle that? Okay, my water pipe broke. That's an event, right? So you will look through your name cards and you find, okay, need to find plumber. Oh, okay, here's a name card of a plumber. You call the plumber, call back, okay, and say, well, you know what? I can use your service right about now because my kitchen is 2 inches underwater. Okay, so that's the mechanism of a callback. Am I doing okay so far with that analogy? So the plumber is an event listener, and you owning the house, the homeowner, is the Android system. So when the Android system says, oh, somebody just clicked here, who can handle it? It would just look at the name cards and say, okay, which button is getting clicked again? Oh, it's that button. Let me see if anyone has registered and say that it can handle that particular event. Look at the cards and go like, oh, okay, this person just registered with me earlier and say that he or she can handle that button click. I'm going to call that person and say, hey, you know what? This button was just clicked. Go handle that. Okay? So that's basically what a callback is, or the concept of a callback is. It's also called inversion of control, which is a really kind of fancy term of referring to, it's pretty much the same thing. Yeah, well, they always have to invent these names to be technical. Okay, so this is the chain of stuff that happens, when something happens on your screen. When you touch a button on an app, this is typically what happens. Well, greatly summarized, of course. The first thing is you touch the screen, and the physical touching is causing your touch screen mechanism, the electronics, to register a capacitance change, and therefore the hardware of your touch screen, or the chip connected to your touch screen, will generate what we call an interrupt because of the hardware physical event that actually just happens. The interrupt happens, and then within the Linux kernel, a particular ISR or interrupt surface routine, which you can just look at it as a subroutine that is kind of specialized, will get invoked. In other words, some kind of logic, will actually execute, but that's in the Linux kernel part of your Android system. The ISR, or the interrupt surface routine, will first interpret the hardware event. In other words, it would basically check with your touch screen controller and say, hey, you called me, what's going on here? And then they will talk, okay? So the device driver, the ISR will interact with the touch screen controller and figure out, okay, there's a touch event just happened, but where is it? Okay, where is the values, the X and Y of the values of the touch event? It will get it from the touch screen controller. And then at that point, once it gets enough information and store that, it will basically submit a token to a thread, and basically there will be a thread somewhere in the system waiting for something like this to happen. Okay? So the interrupt's job is to say, okay, something that you were waiting for just happened. Okay? Now you can go ahead and resume execution, and my job is done. My job is just a messenger. Okay? I'm just going to the hardware. Okay, grab some information from the hardware, which is the device itself, give it to the thread that has been waiting for that thing to happen, and then my job is done. Okay, the interrupt is done, the ISR is finished. And then the next part is, okay, the thread that has been waiting for the touch screen event to happen will resume execution. In other words, okay, I've been waiting for a touch event for a long time, and now it actually happens. So it will resume execution. This is still a part of the Linux kernel. It is the device driver that is executing now, that is running. So this thread will continue the processing of the hardware event. In the case of Android, this thread is likely to generate an event to the Dalvik virtual machine, which is the emulator inside an Android system, so that you can run Java bytecode in the system. So the Dalvik virtual machine will now suddenly get an event and say, hey, a touch event just happened. But by the time it gets to the Dalvik virtual machine, it's already processed. Okay, in other words, the coordinates is already processed. It's not just the value of the capacitance anymore. You actually have the coordinate on the screen at that point. So the Dalvik virtual machine has control over this, and it will go through the Android framework, which maintains complex data structures of what screens are active, what apps are running at this point, and what buttons are on which screen, and so on and so forth, right? So it will go through all that data structure and figure out, hey, who's the active activity or screen at this point on the screen? And of this screen here, is there a button, or what is at the location of the touch event? If there's nothing there, then the screen itself is getting the touch event. On the other hand, if you have a button at that location, the button is going to get the event. Am I making any sense so far? So the Android framework is responsible of looking at the location of the touch event and figure out, okay, who is responsible to handle this? Okay. Now, once it figures out who is responsible to handle it, then it will locate a reference to the Java object that is representing that control element on your screen. Yep.
So in the layout, if you have like a rating like those 5 stars where you click on, I want to rate this, like a 5-star, and
Yep.
then you have like another button on top of one of those stars, how does it know which one?
Because every control element has what we call a Z value.
index.
Yeah, so it knows the depth of that particular object on your
So that's
screen.
something you would set then.
Correct. You can adjust it so that you can position a button to be behind something or on top of something. Typically speaking, unless you're talking about the background screen or something that is supposed to be something to the backside of something else, it is usually not a good idea to have 2 buttons overlapping.
Yeah, I agree. I was just curious.
Because when they do overlap, then you have to specify the Z order, which is which one is actually on top of which one. But yes, based on the Z value of a button or whatever interface you want to use, it will know who to send that event to. Okay. Now, once the framework locates the object that is representing the button, now what are we going to do? Well, in Java, all objects are referred to by references. In other words, the Android framework has references to the object representing the button in this case. This object has to be of class Android.widget.button, which is a internal class that is defined. We took a look a little bit earlier at the manual of this particular class. And any button or any object of the class button has a default method of handling clicks, okay, which is the onClick method. When you look up the onClick method of a class button, it defines the default behavior of a button that can be clicked, that can be touched, which is great. But you probably want your button to do something specific to your application, right? You want to attach something that it will activate when a button is clicked. So the question is, well, how do I do that? Okay, there are several ways to do it. So this is one way to do it, is to implement your own subclass of the class button. Okay, and this probably has to be public too. But the point is, you are using the button class already supplied by the Android framework, and you extend that class so that you are overriding the onClick method to implement your own logic. Well, that all sounds good if you look at, if you ask any professors teaching object-oriented programming classes, this is the right way of doing things. You're using inheritance and you're extending or you're overriding a method to make it more specialized. So that's all good. So there's a problem with this approach. The problem with this approach is you have to link the subclass to an actual button. In other words, yeah, we can define a class that can handle different type of logic, but how do you let the Android framework know that this button on the screen is not a regular button, but this button needs to be an object of this subclass of the button class? That really is the big question. As it turns out, that is not that big of a deal. You can do that with the layout XML file of an activity. In other words, in that file, in the XML file corresponding to the layout of an activity, it also outlines, it tells the Android framework, how do I create objects related to this particular control element? So now you can say, hey, instead of using the default button class to create an object representing this button, I want you to use my specific myButton class to do it. So that's okay, that's fine, but that's only the first obstacle. The second obstacle has to do with the subclass that we are defining is not connected in any way to the rest of the application. In other words, an object created out of this subclass, how does it connect to the rest of your application? Well, by default, it has no knowledge whatsoever of the app itself or even the activity itself. So now you need to implement your own logic, okay, additional methods, so that the button or the object you create out of myButton will know, how to handle it. Okay, so you have to say, oh, you know what, this is the rest of the activity, and this is the rest of the data related to this application. So you will have to, make all those links to the rest of the application, which is kind of tedious.
So in the application, it will instantiate this button and pass to it.
It's
So
not your application instantiating this button. Okay, this is all handled by the Android framework. The button is created. Okay, it is allocated and initialized by the Android framework. It is not by your own code. In other words, by the time your activity, your screen has control, by the time it gets to the onCreate, handler, this is already done. It's already created. So the only thing you can do at that point is to say, oh, this object is already created, but I can use additional set methods that you will have to specify in your own subclass definition and say, I want this button now to know these other things about the application itself. Because unless you make those calls to associate the button with the rest of your application, it's standalone. It just knows that I'm a button. Great. Where's the rest of this application? I don't know.
Maybe I'm a little bit confused. So different applications may define different buttons, right?
Because you want the buttons to behave differently, yes.
And are those buttons objects within the application?
Okay, let me go through this, with Eclipse once, because once we go through this once, you will definitely see what I mean by that. Okay, so I'm gonna use Eclipse right now and kind of demonstrate that portion. So what I'll do is I'm going to create an application with one button and not anything else. Everything is just default. This is also a part of your homework assignment. Problem occurred. Plug in. I wonder if that would. Nope. Cannot get started. Let's enable to load class. Okay. That's all right. Let's see if that helps. So I'm gonna use this. I'm gonna do the simplest thing to get to that point. Okay. So I just call this simple. I'm just gonna get to the point as quickly as possible to kind of show you what I mean by that. Okay, so now we have the default, everything is done. I'm going to go to the resources, go to layout, and go to the main screen layout here. And the only thing I'm going to do is to drag a button over here, and that's it. That's my app. All right? Are we doing okay so far? Okay. So now the question is, what about this button here? Well, let's go back and look at the source code of the program. Do you see anything here that has anything to do with that button? Absolutely not. And what is the entry point of your own code when you start up an application? On create. Okay, on create is the entry point of the portion that you have control over. Okay, so now the question is, if I want this button to do something, that is specific to this application, what am I going to do? Well, once again, I got two approaches. I can define a subclass for that button, and then I have to go to a particular file, which I think is this file here. Okay, so if I go back to activity_main.xml, but this time I go to, well, actually this will work as well. If I go to, I'm just going to use the graphical layout here. Look at the XML file. Somewhere along here, it will tell me what class I will use to create the button. And it's not here. I can't remember.
Let's say main activity job.
Say again?
I think it's the main activity job.
No, it's not. This code does not know that. In my notes. Okay, it's in the XML file of an activity. So I was looking at the right file. It should be somewhere here. Layout. These are only the layout control, but not to specify the class itself. Hard coded string. That's not an issue. Should be here somewhere. This up.
The second link, how to extend.
So that's the. Nope, it is this portion here. So we need a section of my own package name, and the button specific to it. that's representing the layout. Okay, I see. So it will need to have this portion redefined basically. Go back to here. Graphical layout. Let's see. Okay, when you right click on the button, should be a way to change widget type. There you go. Okay, I will look up, how to do it, but I'm pretty sure this is the file that defines the class to use to create, to be associated with the button. But that's how you can associate a subclass of the class button to a particular object to specify its behavior. But that approach is not usually preferred because of the restrictions, because it's kind of really cumbersome. Then there are two additional methods. One is called a callback method. And with the callback method, this is the way to do it. You're basically using the activity itself to implement the interface called onClickListener. And then you have to supply your own onClick method here, which will be used as a part of the interface. This method also has its limitation because you can only handle up to one button using this method. So the last method, which is the most general method, which is also the method that is the most flexible, is to do it kind of like this. We are running out of time today, so I probably will kind of defer this to Wednesday. This is how you can use this part needs to be within the onCreate method. So in the onCreate method, you can attach your code like this in order to basically register a onClickListener object, and you can create an anonymous class, within this process. So we'll talk about this on Wednesday, and I will postpone the homework assignment until and we'll start on Wednesday. You're welcome to get started with your homework assignment. I'll show you a homework assignment too, because we are out of time today. This is your homework assignment. It looks like a quiz, but it's not. There's no time limitation except that it will be due in a week. So I'm going to postpone the due date by 2 days. So it will be next Wednesday, because next Monday is a holiday anyway. I cannot really make that a due date. So next Wednesday is the due date of this particular homework. You can work on it now. You can get started right away. Even though it's a quiz, there's no time limitation. So you can actually get started with it, do a portion of it, log out of Moodle, log back in again, and then continue with that quote-unquote quiz, because it really is not a quiz.
Does it have a section you just click save on it?
No, it's just that every time it auto saves. Yeah, it auto saves. So every time you click a selection and you just click save that answer, it will save that choice for that portion. Yep. So I think on Wednesday when we come back, we'll finish up this slide here, and we'll compare the 3 methods that you can use to implement something that is specific to your application when you have a button. Okay. So for the rest of the day, we're going to start the lab time. So for those of you who want to get started with this one, you can get started now. But I can tell you already that the bigger portion of this assignment is the actual coding part, which is something that we're just getting started into, as I stop the lecture.
So is this a lab assignment, or is this just a?
It's a modification of that. Let me show you what it looks like. So if I go to preview, it looks kind of like that. It has instructions and whatnot, and then it will ask you, a question that you can answer along the steps. But it's different in a way because it is set up as a quiz, which means after it is due, you can look at the entire thing. You can print it out. It's easier to review the material in the assignment itself when it's all due. So that's why it's a better way to do it, because with lessons, if you want to review it, you have to start from scratch and you have to redo the whole thing. This one, it will show everything after the due date, including the correct answers. So, are there any questions about the homework? You can get started right away. It's especially the first part. The first part is really just to define a screen with 2 buttons, and also make use of the string resource, to name the buttons instead of just a literal string. So the first portion you can get started right away, and then if you get the first portion done, at least up to the point before we have to write any custom code, then on Wednesday when we talk about the 3 methods of attaching your own logic to a button, then at that time you'll be ready to do the second half of the homework assignment. All right.
So, roughly how many questions are there in this?
There are
Oh, 9?
9. There are 9 questions, but the amount of time that it takes for each question is different. The first bunch will be fairly easy. There's just it's just using Eclipse, okay, the graphical user interface. The last step is the one that you have to do the coding. So that part is going to take you longer, because if you have any type of syntax error or other types of error, it will take you a little bit of time to figure out, okay, where's the error? Why is it complaining? Why is it not doing what I wanted to do? So the last 2 steps will take longer. The first 7 steps, you can probably get it done in half an hour at the most. All right, so I'm going to stop the recorder and